Hi and welcome to another Dech Academy video. Here I have a question which involves solving given quadratic equations using given quadratic graphs. So you'll be given a quadratic equation to solve, but you need to solve it using a graph of a different quadratic equation. And it's a common problem in the WAEC exams, and although it's easy, it's easily misunderstood and it could prove difficult. So I'm going to try and explain and break it down and make it as easy as possible so that these kind of questions will be solved in a flash. Before proceeding to solve that question, it is important you understand the following concept, because if you do, then everything else will make sense. So you've come across systems of equations, or just put it simply, the idea of solving equations simultaneously. So say you have this equation and that equation, and you have to solve them simultaneously. You'll use like the method of substitution or the method of elimination, and you get you get solutions, and these solutions are, you get a solution in this case, and the solution would be a value of x and a corresponding value of y, which satisfies this equation. So for instance, if I use a method of substitution here, I'll call this equation 1, I call this equation 2. From equation 2, y is 3x. If I substitute that into equation 1, I'll get, instead of y, I'll have 3x, and then I'll have x plus 2. And if I simplify this, I get 2x equals 2, which means x is 1. So x is 1. I now know what x is. And because y is 3x, it means that y is 3 times x, which is 3 times 1, which is y is 3. So basically, the solution to these two equations, it's called a system of equations. So the solution to this system of equations, or when you solve these two equations simultaneously, the solution you get is that x is 1 and y is 3. Now, assuming you go back to the beginning and you start from your original system of equations and you want to solve them, but you don't want to use the method of elimination or method of substitution, there's a graphical approach, which you probably haven't been taught because it's not part of the WAEC syllabus, but you're doing the HCSE exam, you probably have been taught this. But nevertheless, it's important you need to understand the concept behind this so you can solve the question I just showed you in the opening part of the video. So the graphical approach simply involves plotting the two graphs and finding their intersection. So I'll just demonstrate it. So the first graph is y equals x plus 2. And if I plot this graph, I get something like this. At x is 0, y is 2. So y equals x plus 2, something like this. So that's this graph. This is y equals, let me do it this way. So the red graph is y equals x plus 2. And I use a blue line for the other graph, which is y equals 3x. And that's something like this. Again, these should be straight lines. So this is y equals 3x. So the solution to this system of equations is the intersection of their graphs. The first graph, y equals x plus 2, is the graph given by the straight red line. The second graph, which is the blue one, is the graph of the second equation, y equals 3x. They intersect at this point, and the point of the intersection is the solution to this system. And if you actually went through the kind of rigor of plotting the graphs and finding the intersection on your graph paper, you'll find that if you draw this line down to the x-axis, and you find the coordinates of the point of intersection, you find that x is 1 and y is 3, which is coincidentally the same as the solution we just obtained. So that is how you kind of solve equations simultaneously if you're using graphs. So you have this case where, so a good way to demonstrate is that you, in the first equation, you have y equals x plus 2. Second equation, you have y equals 3x. Now, for them, what the graph has said is they intersect. That means they have the same, at this point, both graphs have the same y value. If you look at the blue graph, if you go to this point on the blue graph, you see that the y coordinate is 3. On the red graph, or the red line rather, at this point, same point, the y coordinate is 3. Again, the same thing for the x coordinate. At the point of intersection, both of the graphs have the same x coordinate, and that's the idea of intersection. So if you just think of the fact that when they intersect, they have the same y value, that means from the first graph, because y equals x plus 2 from the first graph, and y equals 3x from the second graph, x plus 2 must be equal to 3x, because y must be equal to y. So x plus 2 must be equal to 3x. And that's what I've written here, because at the point of intersection, both graphs have the same y coordinate. So there is a unique point where the y values are equal to each other. And to find that point, you just say, okay, well, the y values are equal to each other. X plus 2 is 3x, because y is x plus 2 and y is 3x for the second graph. And when you solve this, you get x equals 1. And using the fact that y equals 3x, y is 3 times 1, which is 3. So that's the idea. So you got to take a while to kind of digest this, but we're going to move on to the question I posed in the beginning. But let me just reiterate this stance, that when you're solving two equations simultaneously, their solution is the point of intersection. And at the point of intersection, the x coordinate and the y coordinate for both graphs are the same, because it's an intersection. They share a point. So hopefully it will make sense with more exposure to this area. But I'm now going to apply this concept to the question I posed. So now back to the question. So in this question, we've been given a graph. We've been given this graph, y equals x squared plus 5x plus 6. So this red line represents the graph y equals x squared plus 5x plus 6. And you also solve this equation, which is a quadratic equation. And you could easily solve this using the quadratic formula, also known as the almighty formula. You could solve this using the method of completing the square. You could even solve this using a method of inspection. But you're asked specifically to use this graph to solve this equation, which will come across as weird for most of you, given that you can use those other techniques I just mentioned. But the way to do it is to realize that this graph can, how do I put it? This graph has the solutions to this equation, which is why they even ask you to use it in the first place. So let me just put it to you this way. Now, this graph is y equals x squared plus 5x plus 6. Now, in this equation, x and y are variables. And if you look at the graph, every point has coordinates x, y, which is why x and y are variables, because x and y change. Like, they can take several values. So, for instance, if I take this point here, x is minus 3 and y is 0. If I take this point here, x is, say, minus 2.5 and y is minus 1 or something. Here, x is minus 2 and y is 0. Here, x is 0 and y is 6. So you can see along the line, the x and y values vary. So x and y are variables. Now, imagine if, let's put it this way. There is a value that y can take that will cause this whole equation to equal this. Now, that will seem confusing, but let me put it to you this way. Now, imagine if I replace y with 2 here. When y is 2, so what I've just done is said let y be 2. When y is 2, so y is 2, let's put it this way, instead of having y here, I'm going to replace it with 2, right? And that's what I'm going to do below. So when y is 2, we have the following. Now if I simplify this, I get x squared plus 5x plus 4. 0 equals this. So I took 2 to the right hand side. So I have 0 equals x squared plus 5x plus 4, which is the same thing as x squared plus 5x plus 4 equals 0. Wow. 4 equals 0. So notice what happened. We're given a graph, y equals x squared plus 5x plus 6, which is this graph below that is not so visible. And you also solve this equation. So what I did was I wrote down the equation of the graph, and I said, well, when y is 2, when y has a value of 2 on this graph, I get the following. I get the equation I'm asked to solve. So let's put it this way. So let's think of it this way. I have this graph represented by this equation, and I said let y be 2. So y equals 2 is somewhere here. In fact, there's a line called y equals 2. There's a line whose equation, the line y equals 2 has an equation. And where it intersects this graph, so I'm going to extend this. Wow. This graph will go somewhere like this. So y is equal to 2 here on the graph and here. And if you actually plotted this graph and had an axis and stuff, you find out that this point is -1, and this, let me use a different color, is green or something weird. Anyway, this point is -1 and this point is -4. So, and what I'm going to tell you now is that the solution to this equation, or the solutions rather, are x equals -1 and x equals -4. I knew that y equals 2 will give me a solution to this problem. We're not able to find a solution to the problem. But if you're just given this problem, you are going to solve it without knowing anything beforehand. This is how you proceed. So you write the equation of the graph, the given graph. So 5x plus 6. I'm going to rewrite it in a different form. I'm going to write it as x squared plus 5x plus 6 equals y. So I just swap the left hand and right hand side. And then the given equation is x squared plus 5x plus 4 equals 0. Now what you just do, is modify this equation so that its left hand side will look like the left hand side of the equation of the graph. So you always write, anyway, I'll get back to this. Anyway, so what do I mean? So in equation 2, the left hand side is x squared plus 5x plus 4. You want this left hand side to be equal to the left hand side of equation 1. So what do? Well, I'm going to say let's add a term to the left hand side and right hand side of equation 2. And what I'm saying now is that this term is going to enable, or is going to cause this new left hand side to equal the left hand side of the given graph, i.e., let me just move down, x squared plus 5x plus 4 plus alpha, which is the new left hand side, will now equal the left hand side of the given graph, which is x squared plus 5x plus 6. So alpha is a term you add to the left hand side of the given equation that will cause it to be equal to the left hand side of the given graph. So you can easily solve this for alpha, because if you simplify this, I take x squared to the side, I take 5x to the left hand side, and have 4 plus alpha minus 6 equals 0. So I've taken all this to the left hand side. This goes to 0, this goes to 0, and I'm left with this, which I simplified to get alpha minus 2 is 0. So alpha is 2. So basically, if you add alpha to both sides of the given equation, you get a situation where the left-hand side is the same as the left-hand side of the given graph. So the original given equation is this. What I now said is, let's add a term. Or let's modify this equation so that its left-hand side will be same as the left-hand side of the given graph. And I said, okay, let's add alpha to both sides, because if you add something to the left-hand side of an equation, you have to do the same thing to the right-hand side to preserve the equality. And that's what we did here. First of all, we determined that alpha will be 2 as done as above. So I'm going to add 2 to both sides, which gives 6 is equals to 2. So this is our new equation. I'm going to call this equation 2 prime. The equation of the given graph in the form I wrote it in is still this. Okay, so I know this there's a lot of things to take in here, but we're pretty much done now, because now I have the given equation is still this. I just rewrote it in a different form. So this is still the given equation, just rewritten in a different form. And this is the equation of the given graph written in this form. And now you can see that the left-hand sides are equal. Now that left-hand sides are equal, we know that the right-hand sides must be equal. For instance, if I say x squared plus 5x plus 6 is equal to 2. If I'm now told that x squared plus 5x plus 6 is y, it means that y must be 2, because they're the same thing. Which means that now y is 2. And that's basically how you determine that y is 2. And what you do is then plot the equation y equals 2. This is a lot to take in. You plot the equation of y equals 2 here. So say 2 was here. This was 2. The line y equals 2 will be this plot here, and its point of intersection with this graph, the given graph, gives me the solution -1 and -4, which are the solutions to the given quadratic. So this is x is -1, x is -4. So basically, the solution to this equation is x is equal to -1. Oh, the solutions are actually x equals to -1 and x equals to -4. And yeah, it's a lot to take in, but that's pretty much technique. I'll do a summary of the technique again. I admit that was a lot to take in. This topic can be challenging, but it's actually easy if you remember the following steps, which I'm going to present shortly. Now, the basic problem is that you'll be given the graph of an equation. So for instance, you'll be given the graph of this equation, y equals 3x squared minus 2x minus 10, for instance, and you'll be asked to solve a related equation, like a similar equation. So you can be asked to solve this equation, for instance, but you're asked to solve this equation using this graph, and you know that you can solve this quadratic equation using the almighty formula, or the method of completing the square, or the method of inspection. And if you did that, you get values for x. You get x equals 3 and x equals -2 if you actually solved it. But you're asked to use a given graph to solve the equation. So what you do is you take the graph of the equation and you write it in the form where only y is on the right hand side. So you basically, in this case, you just swap the left and right hand side. So you basically have this form. And then you also take the graph of the given equation and you write it out in the form where you write it out in this form where the x squared and x and all those terms appear on the left hand side. So you basically write it, in this case, write it in the form it's been given. And what you want to do is you modify the given, so I'm going to call this 1, the equation of the graph. I'm going to call this 2, given equation you have to solve. You modify the equation you have to solve such that its left hand side will be equal to the left hand side of the given graph. And the way you do that is you can just say, okay, I'm going to add something to both sides of the equation I'm asked to solve, and that thing I'm going to add is going to cause the left hand side to be equal. So if I add alpha to the left hand side of the equation I'm asked to solve, and I say, okay, it must be equal to the left hand side of the graph, the equation of the given graph in this form, you do that and you solve this equation to get a value for alpha. And it's really easy because you can just simplify this by, say take all terms to one side and cancel out some things and stuff. And in this case, you get that alpha is, x plus 8. And so if we take equation 2, in this case, take equation 2 and add alpha to both sides, because at the end of the day you're trying to make the left hand side of equation 2 equal to the left hand side of equation 1, but whatever you do to the left hand side of equation 2, you have to do to the right hand side of equation 2 to preserve the equality. So you add x plus 8 to both sides, and if we do it here, you see that you get 3x squared minus 2x minus 10 equals x plus 8. I'm going to call this equation 2 prime. And now if I rewrite equation 1 just here, just so you can see them next to each other, which is the same equation 1 that we have above, 3x squared minus 2x minus 10 equals y, you can proceed from here, because since the left hand sides are equal, as you can see here, the left hand sides are equal, the whole left hand side here is equal to the whole left hand side here. Since this is equal to this, then this must also be equal to this, because they are the same. I mean, if something is equal to something and that same thing is equal to something else, then these two things must be equal. I'm pretty sure you get what I mean. So what I'm saying is, because the left hand sides are equal, the right hand side must be equal, and that means y is x plus 8. So when y is x plus 8, so if you go to y is x plus 8. So if you look at the graph you're given that y is equal to 3x squared minus 2x minus 10. When y is x plus 8, you get the solution to the given equation. And what you do is say the given graph was, this is just a rough sketch. Let's say the given graph was so say this was the given graph, y equals 3x squared minus 2x minus 10. We found out that y needs to be x plus 8 for this graph to give us a solution to the equation we're asked to solve. So y equals x plus 8 is a graph that looks like this. So the point of intersection, so this blue line is y equals x plus 8. The point of intersection will give you the solution. So that's the idea. It's a lot to take in. So again, you're given a graph. You're asked to solve a given equation. You write your given graph in this form where just the y is on the right hand side. You write your given equation down, and you write it such that all the x squared and x terms are on the left hand side, and you modify the equation you have to solve so that its left-hand side will be equal to the left-hand side of the given graph. And you do that by adding, say, alpha to both sides of that equation, and you determine what alpha is, as I've shown so many times now, and you get a situation where you have the equation you're asked to solve here, and you can see that its left hand side, 3x squared minus 2x minus 10, is the same thing as the left hand side of the equation of the given graph, which means that the right hand side of this or both these equations must be the same, which means that y must equal to x plus 8. And what this is saying is that if you look at the equation of the given graph, when y is x plus 8, the equation of the given graph is the same as the equation we're asked to solve. So you just say, well, I go to the equation of the given graph,